Good morning. My name is Usama Tirra from the Length Division at the Egyptian National Institute of Standards. I'm going to present the activities at our Length Division. I'll start by giving an overview about NIS, then present the capabilities at our Length Division, then give an overview about the research and publication activities at our Length Division. Finally, I'll state the comparisons that we have participated in and the CMCs that we have published at KCDB. Like any other national metrology institute, our main goal is to maintain the national standards and to disseminate them through measurement and calibration services. But as a part of the Ministry of Scientific Research, our goal also is to research and develop new standards and measurement procedures. Metrology existed in Egypt long time ago. In around 2700 BC, Egyptians were using the cubit for measuring length and balance for measuring weight. They had also a well-established metrology system, since they were calibrating the wooden cubit against the royal granite cubit every month. At recent times, in 1962, Egypt signed the Meter Convention. And in 2000, NIS signed the CIBM MRA. NIS has 6 buildings that are located over 150,000 meters square. NIS is only 3 kilometers away from the pyramids. NIS has 6 divisions. They are chemical metrology, photometry and radiometry, electrical metrology, thermometry and ionizing radiation, length metrology, and mass and force. The length division consists of 3 laboratories. They are the primary length standard and laser technology, end and line standards, and engineering and service metrology. I will present now the activities in the primary length standard and laser technology laboratory. The first activity in the BLS lab is the optical frequency measurement. Optical frequencies for stabilized lasers at 633 nanometers can be measured by beating its frequency against the iodine stabilized helium neon laser, which is the primary length standard. Other stabilized lasers that has the wavelengths from 500 to 2000 nanometer can be measured by the femtosecond frequency comb, which is the state of art for optical frequency measurement. Both capabilities are registered at the KCDB. Since we need an optical frequency reference for optical fibers, we have developed a stabilized laser to the 2-photon transition in rubidium at wavelengths of 1556 and 778 nanometer. This capability is registered at the KCDB. BLS Lab offers several laser source characterization capabilities like wavelength measurement, spectrum analysis, spatial mode characterization, and longitudinal mode characterization. The first activity, which is the wavelength measurement, is registered by the KCDB, and the second activity is accredited by the ILAC. Other activities for optical fiber metrology include OTDR calibration, optical spectrum analyzer calibration, and laser characterization. All those activities are ILAC accredited. We have constructed also a calibration system for laser Doppler velocimeters that is based on optical chopper. We have constructed also indoor and outdoor baselines for the calibration of distance and positioning measuring equipment like the EDM and GNS receivers. The second lab is the end and line standards laboratory. The first activity in the ELS lab is the gauge block calibration by interferometry. We have a coaster interferometer that can measure gauge blocks lengths up to 100 mm. And also we are developing a double-sided interferometer. The second activity is the long gauge block calibration by optomechanical technique using the LabMaster measuring machine. The third activity in the ELS lab is in the field of refractometry and polarimetry, which includes activities like calibration of refractometers and quartz plates. The third laboratory is the Engineering and Surface Metrology Laboratory, which offers services that is related directly to the industry. The lab contains activities like gauge block calibration by mechanical comparison, which is registered at the KCDB, and ruler and tape calibration. The lab also offers metrology of complex geometry, like two-dimensional measurement using the profile projector and three-dimensional measurement using CMM. Calibration of moving machines by interferometry also possible using the laser displacement interferometer, and calibration of hand instruments like calipers, micrometers, dial gauges are also possible using gauge blocks or the Mototoy eye checker. ESM laboratory offers also roundness measurement and mechanical surface measurement using stylus. This service is registered by the KCDB. ESM laboratory offers also optical surface measurement like flatness, parallelism, radius of curvature using the large object interferometer. But also it offers surface texture, thin film analysis using the interference microscope. Atomic force microscope can be used to measure surface features with sub-angstrom resolution, therefore it can be used in nanometrology. The primary standard for angle measurement is an autocollimator together with a polygon. With this combination, an indexing table can be calibrated, but we also can calibrate angle gauge blocks, protractors, and levels. Now, I will present an overview about our research activities at Lens Division at NIS. We have published around 35 publications from the last CCL meeting, and we have published more than 100 publications during the years 2010 to 2021, and all of these publications are indexed in Scopus. As an example of our research is the use of the stimulated Brillouin scattering for filtration of one single mode from an optical frequency comb. This research has been published at the Journal of Lightwave Technology with impact factor 4.2. In other research, we have used the optical frequency comb for measuring distance. We have published this work in measurement with impact factor of 3.3. In another research, we measured distance by including this distance inside the cavity of a mode lock laser. And by obtaining the mode locking, we can find distance directly from the change in repetition rate. Using this method, we could measure distance up to 57 meters with precision of less than 10 micrometer. This work has been published in Applied Optics with impact factor of 1.9. Now I will present our CMCs and comparisons at Length Division at NIS. Length Division at NIS has published 18 CMCs at the KCDB at fields like optical frequency measurement, wavelength measurement, surface roughness measurement, step height measurement, and gauge block calibration. We have participated in several international comparisons as a participant, like the comparison of optical frequency measurement and surface roughness measurement. But we have also participated as a pilot for comparisons like the gauge block calibration by mechanical comparison. We are also piloting an international comparison for hand instrument calibration, but also planning to pilot an international comparison for EDM calibration. We have also participated in length-related comparisons at the CCBR fiber optics, like the wavelength for fiber optics and the optical fiber length. We are also planning to pilot an OTDR calibration comparison. Thank you very much for your attention.